Welcome back to topic 47 for Algebra 2, Inverse Functions and Relations. In part 1, we're going to create a mapping diagram for a function and its inverse and also identify, is the inverse relation a function? In our first example here, we have for the function 2, -2, 3, -3, 5, -5, 7, -7. We're asked to create a mapping diagram for the function and then create a mapping diagram for the inverse as well. So we know with mapping diagrams, it goes from x to y. So we're going to list all of our x values, which are 2, 3, 5, and 7, and what they map to, or the corresponding y values that they're paired with. So 2 goes to -2, 3 goes to -3, 5 goes to -5, and 7 goes to -7. So the domain are all of the x values, which are 2, 3, 5, and 7. And the range are all of the y values. -2, -3, -5, -7. Now, in order to create a mapping diagram for the inverse function, for an inverse function, the x and y values swap. So instead, we're still going from x to y, but compared to our original function, what was originally an x value is now going to be a y value, and vice versa. So instead, we're going to have -2 is going to go to +2. -3 is going to map to +3. -5 is going to map to +5. And -7 is going to map to +7. So our domain is going to be all of -2, -3, -5, -7. And the range is going to be 2, 3, 5, 7. So we notice here that the domain and the range relation switches for an inverse relation. And specifically here, we're talking about a relation. Remember, in Algebra 1, we learned about a relation versus a function. Think of a relation as like the umbrella term, and a function is a very specific type of relation. In this case, we're dealing with a function because we have an x value that doesn't map to two different y values. So it passes, in other words, the vertical line test. Now let's look here. Is the inverse relation a function? So we initially have our relation. We have -2 to 1, -1 to 4, 0 to 3, 1 to 1. So what we're going to do is we're going to switch x and y. So instead we have 1 goes to -2, 4 goes to -1, 3 goes to 0, and 1 goes to 1. So I'm going to reorder this so it's actually in numerical order. So if we go in increasing order, we have 1 goes to -2, then we have 1 goes to 1, then we have 3 goes to 0, and last but not least, 4 goes to -1. Now here, notice that we have our x repeats. So we have an x value that goes to two different y values, -2 and +1. This verifies that this relation is not a function, because this x value repeats. That was part 1 for topic 47 for Algebra 2 on inverse functions and relations. Thanks for watching.